Hello, this video is from the VTM group. Today, we're going to talk about balancing. You will know what parts of the grain harvester are balanced on the 9D series balancing stand and receive a brief overview of some rotors. So, let's begin with the history. The grain harvesting equipment was first patented in 1828 when the first combined machine for harvesting grains was invented in the USA. However, the first operational model was designed by Americans Briggs and Carpenter only in 1836. It consisted of a four-wheeled carriage, cutting and threshing devices, and was powered by horse-drawn traction. Almost 200 years have passed since that time. The design of the combine has evolved with technological advancements. However, the fundamental principles of operation have still been preserved, as clearly seen in the photo of the world's first combine. The mechanization and automation of farming equipment have led to an increase in the rotation speeds of combine rotors, which became the reason for the necessity of balancing. In this video, we will find out the typical design of a grain harvester, which consists of several main assemblies containing parts that require balancing. A component such as the header is designed to mow, collect, and transport the grain mass to the thresher. It includes a reel whose function is to catch the stalks, guide them to the cutting unit, support them during cutting, and direct them onto the header platform towards the auger. The reel is a modular component with movable elements. Balancing rotors of agricultural machinery with movable elements is a quite complex process, as the cumulative vector of imbalance can change its direction and magnitude from start to start, considering the unbalanced mass. For this reason, moving parts, such as the knives, are removed prior to balancing and not reinstalled on the shaft until the repair is complete. In this case, the only limitation is the adjustment and arrangement of the knives by weight, which may not always give the desired result. The PAK1 software of the 9D series balancers supports the balance result averaging function. This feature allows for a fairly accurate determination of the magnitude of variable imbalance in rotors with movable elements. This function is unique as it requires complex calculation algorithms. Movable elements are not the only challenge for the reel. The length of this reel and the auger of the header are equally problematic, being the most dimensionally significant parts in the combine. The customer can order a rack of any length when purchasing a balancing bench. This is an important advantage. A lot of people are willing to work on the reel. The reason is that the part simply does not fit on the stand. The second crucial component of the combine header is the auger. It funnels the flow of cut stems and delivers them to the floating conveyor of the inclined chamber. The cutter bar auger is one of the largest parts of a combine harvester. Inconveniences during balancing arise not only because of its size, but also because of its design features. Spiral blades are welded along the entire length of the auger. This limits the possibility of using a belt drive. Typically, the auger is rotated by the cardan joint of the balancer's axial drive. Customers who choose a combination balancer configuration with both belt drive and axial drive do not encounter these difficulties. The next component of the combine header is the floating conveyor of the inclined chamber. It is used to transport the harvested crop from the cutter bar auger to the threshing chamber. This assembly typically includes shafts and pulleys, which are also balanced during combine maintenance. The harvested crop then enters the threshing machine with drums. Their job is to completely separate the grain from the ears with minimal damage. This operation is made possible by the design of the drums with diagonally arranged beater surfaces. The grain is threshed by beating. The threshing unit consists of an accelerator drum, a threshing drum, and a beater. All these components have a complex design, and in most cases, they are rotated by the axial drive of the balancing stand. The beater is designed to separate the straw from the grain. In the classic combine design, a conveyor board is part of the cleaning system. Its purpose is to feed the threshed crop evenly to the cleaning sieves. The sieves are designed to separate coarse debris from the grain. To distinguish light, straw-like particles from the heavy ones, i.e., the grain, a fan integrated into the cleaning system is employed. The fan can be easily balanced on the 9D series stands using a balancing mandrel. The software of the balancing stands in this series is adapted to work with components like shafts and single plane parts, such as the fan wheel. Another component in the cleaning system is the grain auger. Its task is to transport the cleaned grain into the hopper. The main challenge in balancing transport augers is their length and insufficient structural rigidity. This combination often leads to the rotor bending under its own weight. Gravity and centrifugal force try to change the geometry of the auger as the rotor accelerates. And its stiffness tends to bring it back to its original state, causing an auto-vibration effect that leads to increased vibration. The only way to combat this effect without altering the auger's design is to balance the rotor at speeds where the centrifugal force is not too significant. Therefore, the balancing systems manufactured by VTM Group are designed in such a way that balancing can start at rotational speeds of up to 400 revolutions per minute. In addition to the above components, parts such as gears, pulleys, and sprockets are also subject to balancing. These parts are found in many mechanisms of combines and other agricultural machinery. It is important to remember that the combine has long been powered by engines, not horses. Therefore, it consists of an engine with drive mechanisms that drive the working parts and the chassis of the combine. Every classic internal combustion engine has a crankshaft with a flywheel that must be balanced during repair. The 9D series stands are designed from the outset to handle components with narrow necks where access is restricted due to the close proximity of components. Therefore, balancing crankshafts on these stands does not pose a problem. In addition, the supports of the dynamic balancing stand were designed for safe operation with dimensional components having a significant initial imbalance. Almost all internal combustion diesel engines are paired with turbochargers. Their balancing is also possible with the precision of the 9D series stands. We have reviewed the main components of the combine harvester that can be balanced on the 9D series stands. However, we settled on the classic model. There are many variations and types of balancing components available. We hope these examples will help you improve your work efficiency. That brings us to the end of this video. We wish you professional success. See you again.